All right, so in expanding how we're using linear equations, we're going to do some word problems here. And actually, I guess I could say that more what we're doing is modeling situations using linear equations. Not so much just these, just taking it off of word problems. We can model different situations. So what I suggest is we go through here and you look at the different questions. There's not going to be an official I do and you do. What I would say is pause the video, give yourself a chance to read the question and think about what each part is asking you. So each slide here will be a different aspect of the question. So the situation is Pauline's Health Club is an enrollment fee of $175 and costs $35 per month. So important information here, $5 per month, and then set $175 to start out with. So as you get to do more of these problems, it'll be more clear when we're talking about writing an equation. And generally speaking, when we're talking about writing an equation, we're talking about y equals mx plus b, but it'll become more clear where do we get the values from? Like where would 35 fit into here? Where would 175 fit in here? So the default way, though, if you have no other way to figure out the equation, is to do what this asks you in the first step to do, which is fill in a table to show the total cost for Pauline after 0, 1, 2, 3, and 4 months. So because these are the values you're kind of selecting, you're picking to plug into the situation, even if we weren't told this at the bottom, these would be your x values. So the x values are going to be the number of months. The y values then would be, well, what changes based on what month it is? It would be the total cost. So if it's month 0, month 1, month 2, month 3, month 4, you just want to think about what the situation's asking. Well, if it's no months in, if Pauline's just joining the health club, no matter what, she's enrolling, it's going to cost her $175. From there, she pays her $175 every month after that, it's going to be $35 more. So after 1 month, she adds on $35. 2 months, she adds on $35 more. 3 months, and then 4 months. So hopefully I calculated this correctly. There's each of your months. So how do we write an equation off of this? Well, now all we have to do is pick 2 points, figure out the slope, the change in the y, divided by the change in the x. So maybe y2 minus y1 over x2 minus x1. The slope, the m value for our equation would be 210 minus 175 is 35. 1 minus 0 is 1. So the slope would be 35. And then what would the y-intercept be? Well, you could solve for it, or you could look and notice right here we have the point 0, 175. So that means 175 is your y-intercept and is your b value. So the equation would be y equals 35x plus 175. We're talking about slope-intercept form. Could you write it in point slope? Sure, but with what we're going to be doing with the equation, it's going to be much simpler to have it written in this format. So if you notice, 35 and 175, they didn't just come from nowhere. Notice what we had highlighted in the question initially. It's kind of like you think about your y-intercept here. What was it in this situation? And this is going to be generally true. If we're writing equations in slope-intercept form, which we'll see an occasion where we're not going to in a second. But when we write an equation in slope-intercept form, it's like this is our initial amount. Initial amount of money, initial amount of whatever the question's asking about. And then what would 35 represent? Well, think about what slope represents in general. We call slope, another word for slope would be rate of change. So this is same thing. In our question, what's the changing amount? So the rate of change is every month there's a change of $35 more that it costs. So these ideas right here, keep those in mind, and it'll help you a lot with your writing equations for linear situations. So if we continue, what other things might you be asked to do? Well, you might be asked to create a graph, and it says a graph with months on the x-axis. Months will go horizontally, and then the total cost in dollars will go vertically. If you're thinking about this, when we've done this before with kind of the real life problems, as far as months in total costs go, would it make sense to have negative values? For neither of them would it make sense. So we really want to isolate. We're just going to be in the first quadrant. So if we're going to graph this, we want to graph this just like we'd graph any other line. We want to start with the b value. So think about the song you guys got to watch in class. Start with the b value. So I'm going to change my scale here so that my b value fits on here better. I'm going to go up by 50 each step here. And then for months, because they're pretty spread out, I'm going to actually give some more space here to the months, since these numbers aren't getting big fast. So I'm going to go ahead and change my scale so that we can get a pretty accurate setup here. But I want to graph my b value first, so 175 would be right here. And then how do I graph from here? Well, I use my slope as my rise over my run. So that's 35 over 1. So I'd want to go up 35, which would be about here. We said the next value is 210, and then over 1 month. So no, it's not over one space. It's not up 35 spaces. I have to take consideration of what my scale is. So up 35 would put me about 245 over 1 month. Up and over. I can kind of just continue my line here, and ideally I would have a ruler here, but unfortunately I do not. But you can see how my situation, even if I just picked the points to graph them, they're all going to form this straight line. The rate of change is constant. The rate of change is $35 every single month. So important things on your graph: note the scale, note the labels, so that we can easily read what the graph is supposed to be showing. Okay, and this is going to be the part that is the application. And so we've done the slope piece, and we kind of already talked a little bit about that just a second ago, but thinking about the slope, 35 over 1, to figure out what these values are, or what these values are representing. Remember, change in y over change in x, that's what slope is. So we consider what the y units are. The y units are money, their cost, the total cost, and the x units are month. And you can look in the question and obviously see the slope means the cost is $35 per month. And then it's similarly, we want to treat the y-intercept. If we do 0, 175 and say that's the y-intercept, what does this mean? Well, think, what does the x value mean? It means the number of months. What does the y value mean? It means the total cost. So what is the y-intercept telling us? It's saying when you start out, no months in, the total cost is going to be $175. So why do we worry about making an equation, interpreting these things? The main idea is, and we'll use this kind of going forward, is from this we can make predictions. We can use it to say, okay, 5 years from now, how much is it going to cost in membership for Pauline if she keeps on this same path? So for 1 year of membership, we'll think about what X represents. X represents the number of months, so make sure you're considering your units here. If we want to figure out how much it costs, what's Y, we're going to plug in the number of months. Calculate 35 times 12, which is 420, plus 175 would give you, it costs her to join the gym, stay a member for 1 year, it's $595. So this kind of setup can be used to model a lot of general situations. There are plenty of situations where a linear model is not appropriate, but when you have something like this, which is a constant change, remember that's our definition of what it means to be linear. And so y equals mx plus b, or maybe standard form, ax plus by equals c, or potentially point slope form, may be appropriate to describe different situations. So we'll practice this further to just work on your application of these linear equations.